Hello, everyone. How are you doing? I trust you are all doing great. James from JTS Maths Tutoring here. Today, we are going to be looking at a linear system of three unknowns with infinitely many solutions from Unisa Linear Algebra 1 post assignment 1 questions. All right, let's get going. Solve the following linear system: 3x minus y plus z is equals to 2 and 2x minus z is equals to 2. They want us to choose the correct answer from these given options right here. Okay, so there are plenty plus methods that you can use to solve this question. I've just decided to use this too. So, okay, cool. Let's look at the method of substitution, which is what I've used here. So from 2 here, you can either solve x in terms of z or vice versa. That means x or z can be a free variable. So in our case here, I've decided to solve z in terms of x, and I'm going to solve x in terms of z when we use the Gauss-Jordan elimination later on. All right. So from 2, we have z is equal to 2x minus 2. So we are going to 1, that is equation 1, and that gives us 3x minus y plus 2x minus 2 is 5x minus y minus 4. You transpose this 2 to the other side, you're going to get a 0 here. So what I'm going to do here now is that I'm going to solve my y here in terms of x. Right. I'm going to solve my y in terms of x. So I'm going to assign an arbitrary value to x because that is the free variable. So let's say x is equal to t. Hence, the general is going to be equal to, remember it was 5x minus 4. It's now 5t minus 4. Z was 2x minus 2. It's now 2t minus 2 with t being an element of all real numbers. So this is just a general solution. If you want a particular solution, you have to substitute any value for t as long as it is an element of real numbers. Beautiful. All right. Now, looking at the Gauss-Jordan elimination. All right, so making use of my down here is to convert the given linear system into an augmented matrix. Then I start playing around with my. So remember, guys, I want this 3 where this 3 to be a 1, and I want where this 2 to be a 0 here. So remember, when you're doing this, you have to do it column by column, but it's not always going to work that way. It depends with the situation. But the ideal way to do this is to do it column by column, and also avoid the introduction of fractions at an earlier stage. All right, cool. So I could have divided by 3, but I can see I can actually get my one where I want it to be without me dividing by 3. So, okay, row 1 minus row 2 to get a new row 1. 3 minus 2 is going to give you a 1 there. Minus 1 minus 0 is going to give you a minus 1 there. 1 minus minus 1 is going to give me 2 right here. 2 minus 2 is going to give me a 0 right here. Beautiful. Right now, I want this 2 right here to be a 0. So minus 2 row 1 plus row 2 to give us a new row 2. Minus 2 multiplied by 0, we want it to be minus 2 multiplied by minus 1. That's going to give us a 2. 2 plus 0 is going to give us a 2 right here. Minus 2 multiplied by 2, that's going to give us a minus 4. Minus 4 plus minus 1, that's going to give us a minus 5, which is what we have right here. Minus 2 right here. All right, I want this 2 right here to be a 1. So there's no way I'm going to run away from fractions now. So I'm going to divide row 2 by a half, and you're going to get a 0, 1, negative 5 over 2, and the 1 right here. So I now want this one right here, this negative 1 to be a 0. So it's going to be row 2 plus row, where we want it to be 1 plus minus 1, that's 1 minus 1, which is going to give us a 0, where we want it to be right here. Then negative 5 over 2 plus 2, that is going to give us a negative half. 1 plus 0 is going to give us a 1 right here. So beautiful. I'm happy I actually have it in the corresponding system of equations from what I have right here. It's going to be x minus z is going to be equal to 1. So solving for leading variables, we get x is going to be equal to half z plus 1. Y is going to be 5z plus 1. We can see from this that our x and our y, they are depending on z. So z becomes the free variable. So I'm going to assign an arbitrary value to z, say t. So z is going to be equal to t. Then my general solution is going to be equal to x is going to be equal to half t plus 1. Y is going to be 5 over 2. T plus 1. Z is going to be t, with t being an element of what? of real numbers. There we are. So I'll leave it up to you now to go back and check the options. So I want you to see what I have right here. There are plenty plus ways of actually writing the correct solution, depending on which variable we have chosen to be the leading variable. Thus, we could get different parameterization of the same line. However, it is important to note that all those different parameterizations, they just describe the same set of points. And what is also going to help you if you are in an exam is actually in terms of Y and Z here. So it will be whatever of you to solve this in terms of X, because you can actually see that this solution which we get when we have solved everything in terms of X is not part of the solutions there. All right, guys, this is all I had for you today. Allow me to do what my mama taught me. A good visitor knows when to leave, or she would say a good dancer knows when to leave the dance floor. Till we meet again, be rest assured that at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Adios, amigas and amigos.